sort of here's where we are for the class. So last week we talked a lot about inspiration. We did a little bit of setup. This week we're going to do style transfers. Week 3 is going to be paired GANs, which is some of the segmentation stuff I showed you, some of the next frame prediction, and cycle GAN. And then the last week we're going to do a thing called style GAN, which is just like bigger data sets, and it basically reproduces images that are fake or like in between images. So with style transfer, and I showed this a little bit last week, like there are a lot of ways you could do style transfer like by yourself, right? So we already showed, like some of you have already started playing with how to do it in Runway. But there's all these like apps that exist that like you could like, I think Prisma and Style App are like things you can download on your phone. You take a selfie and then you pick Van Gogh and like it turns you into Van Gogh or whatever, right? So these exist. Like I would say if you're gonna do really, really simple stuff, these are free. So like not being charged by the minute or by the hour would be great. So like you can play with them. A lot of the time, I think with DeepArt you can upload your own style image. But with stuff like Prisma and Style App, I think it's like they have predefined images, right? So it's like Van Gogh or like Kandinsky or like any of these like famous artist types of things. DeepArt's a little more interesting in that you can like upload your own style image. But the thing about them is like you can't tweak any parameters and you don't really have any control. So even like we saw with Runway, when you upload 2 images, like you can speak a little bit about what the image does and what it like looks like, but you can't really get into fine tuning like how a thing works. And like I'll go through the class about showing like how we can actually tweak things to like do what I think are like a little bit better versions of these things. But know that these exist, so if you want to just start playing around for free, like these are worthwhile things to look at. I think the other thing is like, so one of the things that's really interesting about machine learning is that like it's a very academic space. So the way that like a lot of these things happen to be produced is like some lab, like that's usually tied to a university, will write a paper, and that paper will be like studied by other machine learning scientists or machine learning experts, and then like maybe a year later someone will actually like share the code with how it works. So style transfer started, I think maybe about 5 or 6 years ago, and it started with this paper which is called a neural algorithm of artistic style. It sounds about as scientific as you can imagine it is. And you can go on like online and like, so it's linked from this slide deck. You can go online and read the paper. I think a lot of people will like tell you that like you should read every like machine learning paper to learn how the thing works, and like it's kind of true, but like it's also like I generally find these things are like they're really boring, and honestly they use a lot of jargon that are not like the easiest things to read. So like usually what I'll do is I'll play, go for it.
I just have a side question specifically about this culture of like releasing white papers about like kind of developments in graphics technology. Like on YouTube, there's like a lot of like SIGGRAPH presentations and other kinds of like white papers that are sometimes presented as videos. Mm-hmm. Is that something you can expect regularly of papers like these, or are those like significantly watered down and specifically for like what they present?
I would say the videos, like that generally means that someone's like it's been accepted at like a high level, and like SIGGRAPH is like kind of like the like penultimate version of like, it's like cool, like I wrote this paper and people really liked it and I got invited to talk at SIGGRAPH about it, right? So it's like those are maybe like the best of the best. I think you're also seeing more videos happening in part because it looks cooler, and also because those videos are usually done by like NVIDIA, so like they also want to productionalize it. So the thing about a lot of these papers is they're done by scientists at schools, where like the university is like, the number of papers you submit for academic research is like tied to your standing academically like at this university. So it's kind of interesting in that like this is a requirement. Like there's always a paper. Whether or not there's a video and demo and code is like another thing. But there's always a paper about it. There's a site called Archive, even though I will always read it Arxiv, but they will always have papers. There's almost always, if you find a demo online, it's almost always linked to the paper as well. So you can read through these things. They're boring. They're like filled with jargon. It's sometimes really hard to read them, but it is worthwhile to sometimes just like glance over it and be like, what is this thing? It also will usually show you how they train stuff. which is also really helpful to then learn how to use it. I won't go too deep into this one. It's there if you want to read it. There's also been like, usually what happens is someone releases a like really like crazy paper like this one, and then like other scientists like every 6 months or every year will like improve it or like write a new paper on like, hey, I improved this using this thing. So there's a link here to like 5 other versions of this that are like slightly more modified or improved. Oh, interesting. This is a link to there's some like this is a description of like how it works, but I don't, and you can read that if you want to, but like what I would say is like this is the most important thing to learn. So remember how I was showing that diagram of the networks where it's like here's a bunch of dots, 768 dots, and then there's 10 dots on the other side, and there's dots in the middle. And those, remember how I said those dots in the middle are like hidden layers, and like we don't really know what's going on in them. So what's really going on in them is they're trying to figure out like certain levels of an image, right? So like if I were to say like, hey, can you describe Van Gogh for me? They might describe, you might describe color, or you might describe like individual details of like how he uses swirls a lot or he uses dots. But basically what those layers learn is essentially that. So like if you look at the top here, like this is a network, and they basically have pulled out those individual layers and like through some math like reverse engineer that layer, and that's what you're sort of seeing represented along the top here. Like this is a style layer. So it's sort of this is what the machine learning model has sort of figured out is the Van Gogh style. And then similarly, like there are other layers that we think are learning content. So along the bottom here is this image, and the layers that we think are representing the image content. So that's like structural things, like this is the edge of a roof, or this is a window. And as you'll see, like as the layers get deeper, they get a little bit more abstract. But you can still sort of like you can still make out like a roof and a window and other things. And the way a style transfer works is it basically takes these layers and then uses some like pretty complicated math, but it adds them together. So basically all it's saying is like, hey, what if I added this and that, and like what would the image representation of that be? That's all a style transfer is. But it took this guy Gaddis and other people to sort of like go through the layers and try to figure out what each of those layers does. But that's essentially all a style transfer does. So Ari, I think your question was basically like, I noticed that with like 3D models, I get a different representation than I do with a photograph. And I think that's because the way it reads content is probably different with like a very cleanly rendered like 3D model versus a photograph, right? So a photograph is probably gonna pick up more texture or like pick up like more of this little detail, but if it's a super smooth image, it's probably gonna like stay pretty smooth. So then when it tries to apply the style transfer, you get more of that repetitiveness rather than like the textural quality that you might get from other style transfers. That's my guess. That's probably the way it works, but that sort of helps you understand like, you can kind of like, therefore you can kind of intuit like how it's actually working when it works. And sometimes you get an image that like doesn't make sense, maybe because the content is like really smooth edges, and like it's hard to pull out edges for it to read as like an image, right? So if you know this, like, and you start to play with the models, you can figure out a little bit more about how that works. So like I showed last week, the way that these things work is you have a style image and you have a content image. And when you blend them, yeah, this is the model we're going to use. I'll show you how to pull this stuff down a little bit later. So basically when we have a server, we talk to the server through terminal. This looks like, if you're like afraid of code, I know this like looks pretty like gnarly, but it's actually pretty simple. So the top line is literally like all we have to do to get it to work. And the top of the line really just reads like, it says, run this code, which is neuralstyle.py, using Python, which is the language we use. And the content image I want to use is this image, and the style image I want to use is this. So literally all we're saying is take this image as the content image and this image as the style image and do the code that we're going to do.
And the machine image that we'll be setting up, or that you'll be setting up for us, already has like the libraries and stuff that Python's referring to.
Yep.
What are we using from a Python standpoint?
Do you mean like
libraries or frameworks?
Yeah, so we're going to be using a thing called TensorFlow, Keras, NumPy, a bunch of like general like normal Python libraries, but I can show you how to install all that. But when you run this line of code, there's like a bunch of parameters or like these things in dash dash. Like these are parameters or arguments you pass in. There's a bunch of stuff in here that like the code already assumes. So there's defaults for all these things. So if you want to write a really, really long version of this to like really have a little bit more control, like you could do something like this. And all this says is it still says, hey, I still want to use this content image. I still want to use this style image. I want the size to be 1400. So that means whatever the longest size is, the longest side of that image, make it 1400 pixels. The default is 512. So I'm just saying, make me the biggest image I can. Max iterations, I'll talk about iterations, but iterations are basically like, the way this works is it works by looping through the image multiple times to basically like build a better version of it. So this is saying how many times I want to do that. And the image output directory is like, I want to put this image in this folder. As we get through this, or like when we do the demo, like this stuff will make a little bit more sense. But this is all that like you really need to learn. And all of the parameters are in the library, which let's actually just look at it here. So if we go here, this is a library. So I don't know how many people know GitHub or Git in here, but basically this is a forked version of another library. I wrote some custom code in it to make it a little bit easier to do certain things. But if you want to look at all of the parameters that are available to you, they are all here. So we already described content image. We already talked about style image. We actually will talk about some of the weights. But I don't expect any of this to make sense to anyone right now. But I'll show you some of the ones that I particularly play with a lot. And that'll be helpful. And if you really want to go down a deep rabbit hole, you can start to play with more of these and figure out what they do. Or we as a class can like figure out some of that. But usually a good like library of code will like actually like explain all these things. But for the moment, all you need to worry about is the stuff I showed you. But there's more here that exists if you want it.
Is 1400 the biggest?
So
size?
1400 is about the biggest that I've seen that works on our machines. So the size that is here is dependent on how big of a GPU you have on the server. So the servers that we're setting ourselves up with are 16 gigabytes. So you can usually do about 1400. You can maybe actually go a little bit bigger.
Sorry, it's pixels.
It's pixels, right. Yeah. So it also depends on the dimensions of the image. So if you have a square image, you actually have to keep max size a little bit lower. And if you have a very narrow but tall image, you can go higher. And that has to do, again, with like that computation of like, you basically multiply like the height times the width, and that tells you how many parameters you're passing into the network. So like, remember the higher that parameter is, like the more GPU space you need. Right. So what I would recommend is that you'll play with this, and if you set this to like 2400, like it'll basically throw an error and be like, I can't do this. Right. I don't have the space for it. So yeah, so the other thing is like, if you get errors, don't be afraid. Errors are fine. You don't break anything. It just basically couldn't do what you asked it to. Yeah. Okay, yeah, so as I said, like, this is what, like, you can't actually do this when you give it the code, but, like, for us to read this is what we basically just said. So you could, like, take anything between those dashes and, like, turn it into its own line, and then you're basically seeing, like, the assignment you're giving to the parameter or argument. So now I'm going to talk a little bit about, like, how some of these different arguments change things. So the first one that I think is really, really important to play with is max iterations. And max iterations is, again, like how many times we loop through doing this image to see like how like essentially like how well baked it is, right? So it's like, you can think about this almost as like baking, where it's like, if I bake a cookie for like 1 minute at 100 degrees, it's gonna be like still dough. But if I do it at like, I don't know, like 500 degrees for like an hour, it's gonna be a burned piece of crap. And like that actually is like kind of what ends up happening here too. So I'll just quickly flip through these and we can sort of see, like, I think it's also up to like your personal like opinion on when these are looking good. But so this is 100, this is 200, 300. So you can start to see like here in like certain areas you get a little bit more detail. 400, 500, 600, 700, 800. I think it's 900. So like I generally try to keep it within 500 and 1,000. Because I found that like anything above that, it just doesn't really do much. But anything below that, and it can look a little like undone. But you can play with this a lot. It's like, again, these take 5 minutes to produce. So you should feel free to like do a couple versions of each one using different iterations and see what you think works best. The other thing that I think is really, really important, and this is actually like the custom code that I wrote in, which is like the scale of the image. So again, if we go back to these two things here, so what the model is trying to do is it's taking this image at the same size as this, and it's trying to look for like certain attributes, right? So it's taking the texture of this thing or this texture here, and it's saying like, cool, those are the textures I want to use. But sometimes what I find is that these textures are too big for this image. So if we go back over here, this is like the default value where it's saying the 1 pixel of the style to, or like they're the same size basically. If you look at 0.75, so like see how the details here get a little bit smaller? Like especially I think in here you can see it, or like over here. So all you're doing is then you're saying like, hey, take my style image and make it a little bit smaller. Or take my style image and make it even smaller still. All the way down to this, which is like, this is where it gets crazy, right? And now you can really see, if you imagine that style image, and you make it so small, it's actually picking up those individual 3D polygons as its own texture. So we've made it so small that now the model is like reading those as textures themselves, and it's getting really, really splotchy. So I think this is another like really important thing to play with and just sort of see what happens. Because I tend to find that like I'll upload really, really big images of like style images, like 3,000 pixels, and it'll just be too big for that. So I have to scale it down a little bit to make it like normalized. So this is a pretty simple thing. Again, you just pass in style scale and you can change things. And then I also talked about how you could actually just get just pure texture out of this. So what you do is you pass in these two parameters. You pass in a thing that says content weight 0, and you pass in a init image type random. That basically says start with noise. But so again, what's happening here is, remember how I said that in the model, it's adding those two, it's adding style and it's adding content. And the way that it mathematically works is like, it could be 1-to-1, right? So saying, hey, take both the style and the content values and map them 1-to-1. This is basically saying like, don't add any of the content. Like just purely take the style. So this is what a style looks like, where you just take the style of it. And this is basically what the machine sees as that style. It's that pure, whatever was that top graphic. This is like what the machine thinks is the style of that style image.
I mean, that's,
or the texture of that style image.
But it's mapped onto the random like noise map. Right?
Exactly, yeah. So it's not really like actually showing you what it thinks of that image. It's just taking like the textures of those images and applying it to like a random space. And the other thing you can do is, so there's a default value of seed 0, and that seed is like, I don't want to talk too much about randomness here, but randomness is basically like mathematically defined. And what you do is pass in a seed value, and that changes the randomness value. So seed 0 versus, oh, this should be a seed 10. I don't know where it went. Maybe it's at the end of the file. But basically, if you change the seed value, you'll get different textures. So like if you wanted to print just this texture, and you're like, I don't really love that like most of the blue and red is down here, you could change up this random value, and like you would get different placements for those textures.
How do you know like the range of the seed or the scale, or
basically punch in numbers until it breaks. Most seeds will usually be integers, so like 0 to like, it probably goes up to 16,000. But like, yeah, it's usually you just punch in numbers, and if it breaks, then you're like, okay, maybe I'll try something different. There are other ways to do it. Yeah, it's like, part of what I think is like scary to people with code is they think there's like a right, like if I don't do this right, I'm gonna break it. And like the thing is, you're never gonna, like with this stuff especially, you're never gonna break your computer doing this stuff. Like it just won't render an image. But you can just punch in numbers and it'll like spit back an error message at you, and that's all. It's fine.
The randomness is something sequential, or it's not sequential, right? So if you go 0 to 1, it's not going to be like a slight tweak.
No, it's gonna be like totally new randomness, yeah. But the other thing that's nice about this is like, let's say I like this image, but I don't like the fact that the scale is 0.25. Like I want that to be a little bigger. I could type in these exact same values, but change the style scale. And if I kept seed 0, it's gonna be about the same pattern.
So you can make an animation that way. Right? Just
yes, you could. Yep, exactly. Yep, you could. Unless the texture is applied differently. Like that's where I actually don't know. We should try that because it'd be really pretty interesting to try that. I think it would work though. What am I doing here? Oh, so here's an example. This is actually where the server code becomes really, really cool and really different. Is that so? Almost all of those like apps you can download only allow you to apply one style image, but these these libraries allow you to apply multiple images. So what you're seeing here is I've got two images. I've got this image and I've got this image, and they're being like combined. So what it's doing is it's again like basically applying math. It's taking the style of this image and the style of this image, and that's mathematically like adding them together. What it ends up being is more like patchworky kind of things. And I think that patchwork is applied to like value ranges, but I'm not sure about that. It might be something worth experimenting with. But basically what it's doing is it's not adding these things together. So the way to do this is you pass in style images, and then you pass in the two images you want to give it, and then you the next thing you do is style images weight. So again, this is math. This is saying apply each of these evenly. So if you have two images and you divide it by 1, 1 divided by 2 will get you 0.5. But what you could also do is let's say you want a little bit more of the red dot, or this image, right? So this is the second image I passed in. You don't know the names of these files, but I'll tell you, like, this is Davey2, this is Verdina. So now I'm saying change the weights so that I weight it a little bit heavier toward this. So now you've got a little bit more red and blue than this previous version. And you could also do...
the weights need to add up to 1?
I would guess they do, but if they don't, like, it might not break. But yeah. I don't know. Another thing worth experimenting. Like, the other thing is, like, this class would totally be like, how can I break things? Like, that's worth documenting too. So this is one where it's reversed, right? So you can see here, like, if I want a little bit more red and blue of this texture, versus I want a little bit more of these like trippy swirl things.
When you do this, like, how much time do you have to wait until you see it?
It's 5 minutes. It's like 3 to 5 minutes.
Is there anything preventing you from running this on your own machine?
Yes.
Okay.
The thing that is different is running these on remote servers. There are libraries built into the servers that are built by NVIDIA. So basically, every Mac doesn't have an NVIDIA graphic card. If you have a PC, you might have an NVIDIA graphic card, but actually you need NVIDIA graphic cards in order to do this stuff. I've seen some people like hack AMDs, but it like doesn't work really well. So there's two things. One is you could run this on a CPU, but instead of 5 minutes, it might take like 3 hours, which in style transfer time is maybe fine, but like you start to take that to GANs and it's like something that would take a day is actually going to take a month. Like now it kind of sucks. So yeah, and like the way it's basically the reason that we use GPUs is because the way that a graphics card handles GPUs allows you to do what's called serial processing, which just basically allows everything to go faster. Yeah, so basically style transfers you could probably get away with doing it on your CPU, but it would be annoying. Other stuff would be downright impossible.
Don't ever install an NVIDIA driver on your Mac.
Yeah, it just won't work.
Don't do it.
Yeah, it'll be really annoying. The last thing I want to talk about is this is also where it gets crazy. So some arguments don't need values after them. Just passing in an argument says, hey, do this. So there's a thing called original colors. If you pass that in, it will basically take the style of an image, but it will keep the color of the original content image. So I'm seeing some confused faces. Does that make sense? Yeah, okay. Basically what it does, it just drops the color it drops the color layers, and it only shows the content color layers. So this is actually a way of like, you do some really interesting things by just changing the texture of an image, but keeping the image like as is, right? So I think this is actually like a really cool example of where like I was able to create like these very like, you know, swirl like flowing kind of texture to it, but it's still the old image I had previously used. So this is also like a thing that I think is fun to just use, and like again, these are just parameters you can pass in. If you don't like it, you do it again a second time, and you don't need the version. You just leave this out the next time. Yeah.
Is it possible to like pass in like a mask for a specific argument?
What do you mean by mask for a
Like
specific argument?
say you wanted original colors, but like as it approaches the top edge,
Oh, interesting.
keep it.
So
are there inputs for like an image-based type of mask? Or something?
So this library does have masking. I've never played with it, but it does have a masking capability, which means you pass in a black and white image that is a mask, and then it applies that. I don't know if something like original colors can be passed in by mask or not, but it might be something worth playing with. The other thing you can always do is if you already have a mask, you bring it into Photoshop, you do one that has original colors and one that doesn't, and you mask it that way. Like, that's the other thing is, like, don't feel like this is the end of any process, right? Like, always feel free to, like, I did this thing and now I'm going to bring it into Photoshop and do something different with it. This should always be thought of as a tool and not like an ends to a means. So, like, you can always do that stuff. Like, I might personally say, like, depending on how much time I want to spend, I might just do it in Photoshop. If I want to do it once, like, that's fine. If I need to do it, like, programmatically, like for an animation or something, like, that's where I might then do it on a server. So.
If you run this again, will it look different?
Ooh, interesting question. It might look slightly different because the way that those layers work, those layers are activated using, I think, some randomness. So I think they might look a little different. But again, that's something worth trying. I also don't know if this like seed value, because of the seed value, like that might actually keep it the same. This is also a slightly different library than I would usually use. But it's better for the new servers we have, and it'll play nicely with some of the other code we're going to work with.
I think we already got access to the P5000s.
Oh, okay, awesome. Let me just see. I think this might be everything I have for. Okay, cool. Yeah, and then I just have a couple of things here. Like, if you're lost on where to start with doing some style transfers, like here's some things you can start with. So start with like an abstract content image, right? So like again, like we talked about, like what kind of hard edges does it look for, like that sort of thing. Like, what happens if you pass in an abstract style and an abstract content? Like, what do you get? Vector drawn content. So I showed that example where I did stuff with Helvetica. You could try that and see what happens to it. Gradients is style. So this is where I talk about, like, gradients are, like, a thing that sometimes doesn't work at all as a style. But if you want to break things or, like, see what does and doesn't work, like, that's a good place to start. And then, again, like, I think you should always, like, document everything. Like, so if certain images don't work, like, throw that up on a Medium post and say, like, these images didn't work. I don't know why, but, like, I found it interesting. Because someone else is going to come along later and be like, oh, I found this really helpful. And then, like, here's a bunch of links to other artists who have, like, played with this and experimented in certain areas. Some of these, like, I think this top one, which is Style Studies, was done 4 or 5 years ago. And it literally just says, here's a famous painting, here's a content image, here's what it produced. But they did it for, like, 500 images. So it might be helpful to look at that. I think this is Mike Tyka. So like he did some other stuff. Like if you go here, some of what he explains might not actually make sense. This is actually really interesting. I don't even know what that means. This is a thing that he calls style drift, which I think is basically like he iteratively adds. So basically he'll do a style transfer, and then he takes the produced image, and then does a style transfer on top of that one, and then does it again on top of the same image. So like this is what happens when I don't know what style image this is, but he basically like here's like Obama and that style, and then like here's a style plus that looped image until it's like here. I think that's what he's doing.
It's interesting that the drift seems to create artifacts of the same shape, irrespective of the style. Like the way that his left eye gets like a dark splotch above it is not present in the source, or I guess it's sort of the shadow, but the way that it becomes like a blob happens pretty much universally, even though the style is changed.
It's funny though that it's kind of dropped out in the very last one though, right? Or like here it's there, but like it's lost a little bit here. Yeah, I mean, I think there's a lot of like stuff worth exploring. Like this is clearly Van Gogh here, I think, right? Yeah. Like that looks like Van Gogh, and it's like moving more and more toward random noise. Like this is almost that noise style, right? But like it's interesting how it works.
Scream under it, I guess.
Yeah, that's my guess. Yeah, yep, that's right. Yeah. It's funny how at this point it basically looks like that painting again. Yeah, so I mean, I think there's a lot of. So okay, so remember how we talked about those layers and how those different layers have different style associated to them. So what he's doing here is instead of pulling from the last layer, which is like really like that's the texture, he's pulling from one of the earlier layers, which is like texture plus a little bit of content still. And like again, he was like one of the guys that invented Deep Dream. So like this is starting to look pretty deep dreamy, in that it's like also pulling other things. So yeah, there's a lot of stuff to play in here. You can set the layers in this model. So if you want to play with like just singling out a single layer, I can show you where that code is. It's kind of complicated, but I can show you where it is. So there's a bunch of stuff here. Like all these links are like, there's a lot of stuff to like dig through if you really want to get into this and like learn a little bit more. And I would say like Runway is like a good model to play with just to sort of see like, do I like this effect applied to this thing? But because you can't do that scaling effect, or you can't really like tweak the number of iterations, sometimes the results you will get from Runway like won't be as good as you would like. But if you move to the server, like that's where you can actually like tweak things a little bit better.
Yeah, actually, when I was trying like Word Away, I was like, Runway sucks. It doesn't do anything.
Yeah. So again, it's because it's assuming. So the other thing you could do is like you could actually, in the images you upload to Runway, like change the scale, right? Like you could actually scale down the image in Photoshop and then upload it that way. Like that works, but it's like slow and annoying and frustrating. Whereas like something a little bit different is like doing it this way. It like is way easier and way cleaner to play with it. Are there any questions about style transfer before we do the demo of it?